Okay, my friends, this is going to be fun. I have shown this is what light looks like. It is a dipole. There's two whites and two blacks attached together. And the black has all the weight and the white has all the burn. I'm going to show you this happen in an atomic bomb blast. In an atomic bomb, the white goes out first and then the black follows it. I'll explain to you right now. Alright, this is atomcentral.com. Teapot Apple II test house, the little test community they had set up here to see what would happen when the atomic bomb went off. Now here's what did happen. Okay, here's what did happen. They set the bomb off. This is run extremely slow. Boom. The bomb just went off. I stopped it. All you see is bright white. That's it. There's nothing. Now watch this. Not a thing moves, but the house burns. Look at the house burning. Nothing's moving. Nothing's moving. It's not like pushing the house or anything. It's just burning everything that's combustible. Even the wires, the poles. Metal doesn't burn because it's not combustible. And these all that now watch, everything's boom. There comes the black. Now not only that, the black has hit and pushed it away, and it's all going to come sucking back. See it? Watch. It all comes back because there's an empty place in space. All an atomic bomb is basically is so much matter squished into such a small space that they don't want to be in amongst themselves. There's just too much stuff. It just wants to get away from each other. And then they explode it inward, and when it goes out, all the white particles go first. And then the black ones come second, just what I showed you in the atomic bomb blast. So that's what the nuclear fissionable material is it's just too many parts to it. And then when it all gets crushed against each other, all those fields go in, poof, it's all over. But the white is the first to go, then the black, just as I showed you. Well, okay, my friends, you guys know about dipole electron flood theory, I'm sure by now, if you've been with me. If not, just look it up. It's very simple. These two are the particles that exist. This is literally dark matter. It's the muons. They know what they are. They just don't realize they're dark matter. And it is also the source of gravity. Simple as that. And I'm going to explain it to you very simple, because this is what a photon of light looks like. These are the most basic particles there are. Is the dipole electron, they call it gluon. And the photon, which is the next bump up, and then you get up into the proton area. And it's all about areas of stabilization and fields. Magnets have fields. You push them together, there's nothing in here, but you can feel there's a field there. What's it pushing against? It's pushing against some kind of magnetic field. And this is the one that has field. This does not. This does. That's why we've never seen dark matter. It's always inside. It's inside of everything. It's inside of you and your fingers and your eyeballs and everything else. Every proton coats a core of dark matter. And I can actually show you this happening. I see that? That's gravity. And it's also primarily dark matter. And this was done in space in the Russian space station 10 years ago. And they everybody freaked out. What they did was they created a perfect vacuum chamber, which means there's no particles of anything in there. There's no gases, there's no dust, there's nothing of any substance whatsoever in there. And when I say substance, I mean dipole electrons. There's none in there. It's empty. Now, what they did was they injected these charged particles, micron size, tiny, 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 but they had an extra charge to them. All right, and then they let them float in here, and they came in a stream, and they were bounced around, and then they started doing this. And it ended up being the white particles surrounding a completely, totally black spot. 100% black. Which is what dark matter is. It does not absorb. It does not reflect. And it does not, it doesn't do anything. It's dark matter. That's why it's dark matter. And that's dark matter. You're not seeing any of these particles on the other side of it. The only way you can see dark matter is if you can get it on top of white matter. And that's what they have found at Fermilab, at CERN, and everywhere else. And we did too. Once you can get the black particle on top of what's trying to radiate at you, is gone. Light flushing into it doesn't do anything for some reason. And it's just is there. And we've seen the same thing in our experiments using light. Which this is nothing more than, when they charge a particle, it's nothing more than giving it a few extra electrons, or it's giving it a little extra electron. That's all. Because if you get enough of this, it'll spark at you. It'll spark and discharge, and it will always discharge to ground. So what are they doing? They're seeking ground. This is ground. Dark matter is ground. And what seeks ground here on Earth is any of the white particles. They build up in the atmosphere and they can create lightning right to ground. Ground is ground, literally. And basically, it's the stuff you're standing on is dark matter. It has a glowy surface to it. Yeah, it's just like this. But it's dark matter. If you can stand on it or you can push against it, there's got to be dark matter in there, which is the only thing that has substance. There's no substance to the white, none whatsoever. It's just extremely attractive and has no mass that I can determine, and you can see that by an atomic bomb blast where the house just burns up in the beginning because of the white particles are hitting, and it just burns, and then the house sweeps away when that comes. Two separate particles, they're dipoles, and this experiment they did shows it quite well. That's dark matter. I'll show you how our dark matter is exactly the same as that. Now, I showed you what happened out in outer space. They had a dark hole, a black hole basically, in the middle of glowing little ordinary matter. Yes, there is significantly more dark matter than ordinary matter. So in ordinary matter they consider to be blacks and whites together. Because they make up everything. They make up 100% of everything. It's just all it is the black and the white, the dipoles. They make up protons and all the way up to everything. But there is, in addition to that, there's a ton of these black particles just laying around waiting to attach to something. That's what I see. And I believe the Earth is saturated with them. And that even in that space cylinder, that had a bunch more black, and all the pushy ones wanted to attach to it. And it ended up forcing it to create a black hole in the center of everything. Okay, so I say this is a photon of light. And they're only made out of these two particles, and configured like this is what light is, and there it is right there. Those are photons of light. You see the black particles and the white particles? The white particles can get big and small. The black never changes size, and it obstructs light. It stops light from coming to us, and it doesn't absorb it. It doesn't reflect, it doesn't absorb, and it doesn't emit. It's just dark matter, and that's correct. I agree with that 100%. Because of this. That's the particle. Okay, so here we got the particle. And the black is just black. It's just as black can be. And it's the same thing they found at Fermilab. And the only way they can see it is because of a glowy edge around it. The only way we can see it is the same thing, is a glowy edge around it. The black is here obstructing what would be coming at us, which would be something bright. Now, down here, we can see it much clearer. Don't forget, there's attached together, black and white, and this just is colorized, showing the more intense color of the one that's going forward, because it's banging into all the other particles it's hitting. Now, this is done with CMOS, and CERN and all of them now are using CMOS to see these things. Very, very effective way of seeing it. And here's where we can see it even better. The only way we can see those black particles is because they're on top of the white. I'll show you. Here, we accelerated the light through the Venturi down here. So it started to pull itself right out, and the particle became a particle and exploded here, separating the black from the white. And I don't see any reason we couldn't get free energy here, but that's just something we should probably look into. Now, don't forget, you got the muon, which is the black particle, never changed the size. They agree with this. Then you got the electron neutrino, which is the white one, and it goes into a shower. They agree with that. Here it is right here. The black one never changes, and it's, as long as it's on top of the white, you can see it's black. You see it? It's blacks out whatever's coming at us. I can't explain it, but that's the key. It's a strange thing, and it's shown right here too. You don't see anything. There's nothing. There's no reflection. It's not emitting anything. It's not absorbing anything. It's just, I don't know how to explain it, to be honest, because they must be. Well, I'm not sure that they're putting any particles into this or not. Usually they send light into here to make these particles glow. If that's the case, which it could be, you're still not seeing anything here. I don't care whether they're putting particles in or not. There's not absorbing, not reflecting, or not emitting. I don't know where those particles went to. Because if you're shooting a whole batch of light in here, anyway, there's a few things that could be explained, but I think I do understand why they're collecting around this area here. Because there's excess white ones, there's going to be excess black ones. They're dipoles. So the excess black ones are forming their own district. All right, and the white ones want to try to get to them, but the black ones are able to separate, which is the same thing we found. And boy, I tell you, it freaked me out when I could see this, and I'm saying that broke. Those black ones broke off the white, and the white turned into a shower, and now they're reattaching here. Instantaneously, they reattach. So I don't think there's any danger in this research, because you're only working with particles that are light anyway, only they're extremely high energy right here, I would think. Here, I would think they're getting back together, and that's just instantaneously, basically. So, but it's exactly what they found, and the only way you can see them is to have them obstruct your line of sight. Exactly what Fermilab says. The only way they see them is when they're on top of something glowing around them, which is what we have here. Same thing, exact same thing. And we're working in that light range, which is the smallest particles there are. So as far as I'm concerned, this is pretty well proven. What I'm showing is we can separate the black from the white, and the black is literally ground. It wants anything that has white with it to come down to it. And we have more black in the earth than we have, dipoles of the other kinds. the more black particles, the more attraction. That's all moving electricity is. Okay. Dipole electron flood theory says hydrogen gas is the smallest particle, is a single proton, and it's also very volatile. If you spark that, it will explode because it has nowhere else to go other than an explosion. It's at the smallest stable state it can be at. And it does not weigh enough to be gravitationally pulled to the earth. It goes up in the air. Same thing with helium. Now, helium's a different story. Hydrogen is an unstable gas. Helium is different, it's stable, but it still doesn't weigh enough to come to the ground. Yeah, that's why they have the helium balloons, they lift up in the air. Now, I'm saying that 1,839 dipoles make up one proton, right, which would be a hydrogen. All right, there's different states of hydrogen, and that's why there's all different numbers of electrons that are on there. Plus you get static, which is buildup of extra electrons, which are dipoles, and there's all kinds of things going on that they don't take into account. That's why we got to get into the new dipole electron flood theory. And I showed you the photons and the dark matter. And that's dark matter. That's what it is. And that is the attractive source to these. They glue together. They call it as a strong nuclear force and a weak nuclear force. Well, this is strong. This is strong. These stay together basically forever. Cosmic radiation is ionizing radiation. Ionizing radiation means they can knock an electron in or out, which, yes, they can. And we showed that we can squirt them right through the accelerator and just split them and create gigantic showers of them, which supposedly is a lot of extra energy. I don't know. But I think that's what they were saying. And these are the same particles from Fermilab. This is right from their article. And they do exactly the same thing they said they do. And we're working with light, and we can show light accelerating. All this stuff is pretty phenomenal. And this is fission and fusion. When that particle broke apart, that's fission. When it comes back together, it's fusion. And it did both those things right here. So let's talk about gravity. What is gravity? He's going to be screaming about what's gravity? Nobody knows. Well, let's see. Okay, we're going to be talking about gravity, and there it is right there. This was done in outer space by the Russians about 10 years ago. When they did this experiment, these white particles bounced and bounced and bounced, and finally they settled in right here. And they said during the experiment, we contacted the Earth guys who couldn't believe it either. Nobody figured that this was going to happen. They thought it was going to create like a lattice. Everybody was pushing everybody else apart. But no, it collected around a literal black hole. Okay, I haven't watched this, so I'm going to make comments as we go along. But instantly he starts out, what causes gravity? That's a good question. They don't have answers.
What causes gravity? So physics, as you know, this is the type of question, what causes gravity? This is the type of question that keeps physicists up at night. Because physics is, among other things, as you know, the search for mechanisms, the reasons or explanations for why certain things happen the way they do, the why and the how. And if a physicist comes to you and says, and asks you, what causes X phenomenon, and you tell her, that's just the way it is, she'll be very dissatisfied with your answer. And so for the longest time, the question, what causes gravity, was not so well understood. and even a fairly bright guy known as Isaac Newton, even Isaac Newton, someone who managed to describe gravity quite well in the 1600s, even Isaac Newton at some point had to admit, I don't know what's going on. So in the Scholium General, he says, I have not as yet been able to discover the reason for these properties of gravity from phenomena, and I do not feign hypotheses. He's saying, yeah, my equations work really, really well, but the why, I have no idea why. And for the long time, people would say, okay, well, maybe gravity is just like a universal force, and that's just always been the way it is. And if you think about that, that's a little bit too close to that's just the way it is. It is not satisfying at all. And so what is that? What is the mechanism that keeps you seated in your chair and that keeps the moon orbiting around the Earth like that? For the longest time, again, this was not understood until Albert Einstein. And Albert Einstein needs no introduction. In 1915, he finally came up with general relativity, the general theory of relativity, and came up with a mechanism that explained how gravity actually works. And it required us to completely change our perspective on the nature of reality. And so,
I got to tell you, Albert was completely wrong about everything. It's not like it's not a fabric in space. It's an attraction by the dark particles. The white particles are excess white particles, and they collect in our atmosphere and the ionosphere, and there's a whole ton of them, and they're always discharging to Earth. The white particles want to get back to the black particles. That's what electricity is. That's 100% electricity, and electricity is 100% gravity. We are being electrically pulled towards the Earth due to our magnetic interaction with the dark matter of the Earth. The Earth must have more dark matter in it and wants all these extra electrons to get down into that dark matter. And that's why you discharge, you're static, you touch a water pipe, bang, you get the discharge, electricity jumps off you. Same thing with electricity, they call it ground. It should be grounded. That's where it wants to go, into the ground. The white particles want to get back to the black particles in the ground. The ground has more dark energy in it than it has bright energy in it. The bright energy bounces back off. The dark energy stays. When light hits us, it has both of those particles. We see light bouncing back and bouncing all over the place, lighting things up and collecting it to do energy and so forth. Well, where's the black part go? The black part goes to ground, which becomes the ground for everything, which means anything that has white particles, and everything does, is going to go to ground. It's going to be pulled towards ground. And things that are very dense are going to be heavier when they hit the ground because they have more particles in them, which means going to have more white particles. They'll have more dark particles too, but they're going to have more white particles, and it's going to be sucked to the ground. All right, so let's go back to Albert here. He's saying Einstein figured this all out. Let's see well, I showed you already. We can accelerate light. Light is a particle. We've divided the light. I've shown it. It's quite obvious. None of those things would Einstein go along with.
The question is, for example, when an apple falls from a tree, what is the apple falling through? Okay, the atmosphere, so maybe that's a bad example. But what about the moon? What is the moon falling through? Not really anything, right? But it's falling through empty space. But what is space? Again, the concept of space for a very long time was this notion that it was sort of like, there's different ways that people thought about it, right? But the concept of space for a very long time, you could think of it as the sort of background grid upon which things happen, right? So the space is not real in the sense of, like a moon or the earth or, like a table or something like that. But if I want to, I can impose a grid upon it so that I can describe things in the physical world in a better way, in a more convenient way. right? So I can impose a grid, like, for example, lines on a chalkboard. If I want to make a grid so that I can better describe some, planets that are doing something with arrows, I don't know what that was. I just decided to draw it in a moment's notice. But that grid is there to help me with my calculations, right? And it's sort of like an abstract thing, and it's so abstract that if I wanted to, I could actually choose a different coordinate system if I wanted to, right? And as long as I am consistent about what I'm talking about, then it's totally going to be okay, right? And we'll let this guy finish his work here, right? Great, very good. Oh, that's good too. Oh, beautiful. He's an artist. But again, so so space, in a sense, is this background grid. It's like these metric lines that we impose upon things so that then we can describe physical phenomena that are going inside. But it's not real. It's not as though I draw a circle on the blackboard. It's going to change the blackboard, or the blackboard itself doesn't change the circle. But in fact, so you might think that space is like that. Space is nothing. It's just some sort of like a background thing.
No, that's not true at all. It's filled with fields. You see this? This is not just nothing. This is what's out here. These are what's called stacked and layered, with using different focal points, and I don't really know that much about it, so I better shut up. But what it gives you is the field effect of the brightness in these different depths of stacking the layers. And you can see there's areas here that are very bright. There's a lot of activity in this area, and it's dark here. But primarily, they're going to end up being almost equal, more or less. And when light comes through this, it slows down. It does not stay the same speed. That's why the universe isn't being pulled away. That's why light is being pulled away into the red. No, it's just coming slower and slower and slower as it comes at us. It's got to get through all this stuff. There's no emptiness in space, none whatsoever. And they know this. Don Lincoln put in his 2013, when I discovered the same particles he discovered, he wrote a thing saying space is not empty. It's like a bubbling head of root beer, and he's right. I agree with that 100%. And then he had his other article. Well, let me show the other article, because it is the same article that shows our particles. See, he was almost exactly right. This was from February 2013. Empty space isn't empty. It's not empty. He called it quantum foam. It was like the head of a bubbling root beer. And I don't disagree with that at all. Those are all fields. They're fields that are interacting with each other. I agree with that 100%. And this was in the same time frame, 2013, they found these two smallest particles that exist that they could find. And one of them was the black one, the dark matter. It's a muon, and it sits on top of a glowy stuff, otherwise you can't see it. It has to be obscuring some light that's coming at us. And it has all the mass. And this one has literally no mass to speak of, but it has a field surrounding it which gives it a lot of energy. And it has virtually no weight that they could find. I agree with that too. I agree with both of those exactly. Exactly. Because we found them in our particles. These are the ones you just saw in the article. And here's ours. There's no difference. He says the black one has to have a white ring around it, or some kind of glowy ring. And we have the same one. The green, the blue, the red, they all do the same thing. They have a black particle attached. Well, I'll show you. All right, so you see what they said at Fermilab, and you see our particles. This is the red. Now, the next one I'm going to show you is the green, the same particle. No difference whatsoever, only it spins a lot faster. It spins very fast compared to the red. And here it comes, and then it starts showing up here. Now, I'm sure you can see that. And it's starting to charge up enough. I think it's going to flip any second. And this will go behind, and this will come up in front. But I could be wrong. Now, that's the same particle as the red one. There's no difference whatsoever. Zero difference. Only one of them is slow and one of them's fast. So the red would be, let's say, spinning this fast. And they spin, and that I can prove too. And it would be like this. The green would be somewhere down here, so it would be spinning much faster. And I think it's literally going faster, but I'm not sure of that. And then the blue is way down here. And the blue, you can't see the photon, except I can prove it still is a photon. This stuff, it gets really cool. Rod Warren did virtually all of the really top-end stuff here. I did a little bit, but nothing like him. So let's go from here to the blue. Now here's the blue. I can't see that it's two particles, basically, until it gets way out to here. It comes in like a rocket ship, and it's spinning to the right, which means it would drift to the left as it slows down. And we do see it's spreading apart. See how fast the spin was here? And now it's a little wider, 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 wider. It's slowing down. And now we can see there is two white particles in there somewhere. Now, does that prove anything? Well, it's kind of hard to prove from this that it's exactly the same photon. But this happened just by accident. Look at that. This is blue. Shouldn't be blue. Should be red. They all came in red together. And they all came from the same source of frequency. And this one got crushed. So the field, it went zip and made it turn blue. Now it really, it's a phenomenon. Let's just put it that way. And then it drifted back down to its other color, which would end up being here. But it was accelerated by these pushes. That's all I can take out of that. I'm pretty sure that's the case. It got pushed here and pushed over on this side. And it got excited. It pushed it into excitement, and then it brightened up again, and now it's drifting back down to these colors, the same kind of color. That's phenomenal stuff. Rod was a phenomenal guy. He knew what he was doing, and boy, I'll tell you, I haven't had any contact with him for years now, so I'd love to hear back from him, but I want him to have credit for this, and since day one, that's been my goal. That the theory is mine. Dipole electron flood theory is mine. But without his work and his dedication to this, I could never show this with this degree of certainty. And here's the red and the green at the same time. Now, this was not by Rod. This was by another guy. I had a bunch of people doing stuff, but Rod was the guy. Now, this was from Fabian. And these two, the red and the green, came together at the same time. And the red just got pushed out of the way, you see it? It turned it into a barrel roll. Get out of the way. And the green up here, with much more energy, reconcussed his way out here. So I think it's going faster. It's certainly got more energy. And it's the way it barrel rolls. In other words, that photon is supposed to be going this way. They always go straight up or down, straight up or down. They never do this. So this field is pushing the field that's going like this and forcing it to flip around in circles. That's why this is happening. You're never going to see that. I've never seen it anywhere else. It's always straight up and down, even if the photon is going on an angle. As a matter of fact, I can show you that. Here's the photon right here. The photon's going up on an angle, still straight up and down. I don't care if it was going this way. The photon would be just like this. And if it's flat, it's an up spin or a down spin. I'm not making this up. That they do understand. Okay, my friends, I've just shown you actual photons of light dividing, coming back together again, green, red, blue, just everything about them. Angular momentum, and then the froth of space, which is exactly what Don Lincoln agrees with. And this particle is the same particles as ours, except that we use light, which I think was a much better way to do it rather than smashing a whole bunch of stuff together and then digging through the debris, which is what they did. Now, let's take this another step. See, don't forget, in dipole electron flood theory, there's 1839 in a proton, 1840 in a neutron. And they're bringing them, smashing them together, and they're getting globs and bits and pieces, and X's means you can be any size. And all of these other ones, they're seeing the sizes we have. But we started out with light. We started with the smallest particles you can get, other than just a single dipole electron. So we started out at the bottom and could see every bit in detail. All right, because we were just shooting these particles, not all that. We were just using these. And we could accelerate it, and I could see them accelerate. Very simple to see it. All right, and I have shots of just the field just starting to accelerate, and then the particle being pulled out, and then the particle is this particle explodes, and it's the same stuff that they had at Fermilab. So to get back to gravity, we have to understand the dipole electron flood theory, that the dark particles can leave the white particles, they can separate. We separated them. That's separation of the black from the white. There's no question whatsoever. Now, these particles are coming down from space. We know that. There's no question about that. And they can harvest just the white part to make electricity. What happens to the black part? The black part goes into ground to make the ground more attractive. And that it's been an ongoing process. The Earth just becomes more and more attractive because the dark particles stay. The white particles float around and make electricity. They end up going into space as well, yes. I don't think they leave because the ionosphere pushes them back down. So it's, and lightning strikes on Earth 50 times a second. There's so much extra white particles in the atmosphere. They have to discharge to ground. So it's more or less of a recycling of the particles out, and then they discharge in. They come back out along with moisture and, you know, whatever it is. They sort of, it's a cycle. And this is the white part, is the part that is the energy. The dark part stays on the Earth, basically, most of it. All right, here's what I want you to think about. This is all radiation. All right, it's from the sun. It's a solar eclipse, so the moon is here, so we're not seeing the blinding light. Otherwise, you couldn't look at it. So now, what are we seeing? These are rays of actual particles containing a lot of little particles, light and so forth, and I'm sure all kinds of other, almost like dust debris, that type of thing, and who knows, maybe some big stuff. You see some big flares coming off. I don't know, maybe some of that gets out too. But you can see there's a ton of particles leaving here. And they're going. They're not coming back. They're gone. They're going to zip. They're done. The sun does not re-attract its particles. Most other ones do, and that I can show as well. This is from Dylan. Dylan Carpenter took this with his new phone about 4 or 5 years ago. And that's the last I heard from him. I'd love to hear from Dylan again. I can't get through to people now. I don't know if it's my email or not, but anyway, this shows the Zeeman effect. And my friend Mason is working with me now about the Zeeman effect. He has a paper on academia.edu about the Zeeman effect, which is this. It's actually like a magnetic bump. It's like you're pushing real hard, like the blue spectrum. Bam, 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 and then it gets slower and slower. That's what you're seeing here. And light coming from the other parts of the universe towards us is not going the same speed forever. It's absolutely not. There's no way in the world is that light coming through this and not being affected. It's just impossible. And everything that they are judging and talking about, the Webb telescope, we can see now to the farthest reaches of the universe. Well, maybe through here you could, because by the time you hit anything out there, you're going to be way different than there. You're going to be deeper into the mix. This is space. This is not something that you're going to just walk through without not be affected. And these are the particles that are coming out towards us everywhere. And every now and then there will be a real blast at us, and it will cause magnetic interruptions. And you see the northern lights and all that. That is particles coming at us from the sun, from these magnetic disturbances. And out here, way out here, it's millions of degrees. It's only 10,000 on the sun. It's only 10,000 degrees on the sun. But by the time you get out to the solar corona, it's millions of degrees. And that's because this is scrubbing through space. And you see the little red, the red, and it's a lot more. This is spinning somewhere like this, going that way, and these are the poles. This is of the sun. These are the poles. This is just the moon. And this is the slough off. So it's spinning this direction, I would say, and going that direction. Spinning this way, causing more extreme interactions here. And this is sloughing off. That's the way I'm taking it. But these particles are leaving, and they're not coming back. Now, Dylan's shot shows a different situation. These particles are coming back in. You see, they're feeding back in here. They're feeding back up here. I don't think they're getting out and leaving, being pushed forever. I don't know. This is speculation at this point. These need to be looked at. But I see all the dipoles. When I saw all the dipoles, I was very excited. Now, a lot of this is done with time lapse and different focuses and frequencies and stacking and layering. I mean, it's just stunning. Filters. And I don't understand it. But I understand what I'm looking at. And the reason everything is so hot out here is just like this. This is the sun. This is its corona. It's millions of degrees out here because it's scrubbing space, which was that big fluffy particle ball here. It's got to scrub through here. And that's why it's millions out at the corona, because that's the part that's scrubbing through. The ball in the center is only 10,000 degrees. All right, so it's 10,000 millions out here. Same with us. Very, very, very few people understand this. Out here at our ionosphere, it's thousands of degrees. Right down on the Earth, it's, let's say 100-ish. It's 1,000, thousands out here, because we are scrubbing through space just like the sun is scrubbing through space. Our ionosphere is a layer of electrons that are continuously shooting down as lightning. And they're working in gases, they're making fluids, they're doing all kinds of things out there. But that is that's scrubbing our ionosphere. An ionosphere is extremely hot, and there's almost no density to it because it is nothing but white particles. And the white particles have no density. The white particles have no density to them whatsoever. Electricity weighs nothing, zero. Electricity has no weight whatsoever. It doesn't have any weight whatsoever. You take a car that weighs 4,000 pounds, and it's completely empty. You fill it up with electricity, it still weighs 4,000 pounds. You drive 500 miles, it still weighs 4,000 pounds. You fill it back up again, it's 4,000 pounds. The white part has no weight. It has, let me put it this way. I think with a 4,000 pound car, or no, 1,000 pounds, you have a weight of 0.0045 grams, something like that. It's less than a gram. All that electricity weighs, all the white stuff to do all that work. Now, if we could just harvest it right here and take that white, we're good to go. And you could walk around with these things. You know, I've been talking about that for a while, but that didn't go anywhere. Anyway, this is our planet spinning, a globe, scrubbing, and out here it's thousands of degrees. And down on the Earth it's less. But we're working on it. So a lot of the things we've been told just don't hold up when you really look deep. And, you know, this has been going on a long time. This is from February 13. Rod started doing his research right around this time. And it was apparent immediately what we had. And he worked tirelessly. But again, it just didn't seem to want to be looked at, so here we are. Now, this is stunning. This was absolutely stunning. The Russians did this. And they said the guy from Max Planck locked himself in his office for 3 weeks after seeing this. They freaked out. It's absolutely amazing. That's a black hole in space. They created it. Okay, so let's get back to what he thinks about gravity. Here we go.
The grid is there to help me with my calculations, right? And, you know, it's sort of like an abstract thing, and it's so abstract that if I wanted to, I could actually choose a different coordinate system if I wanted to, right? And as long as I am consistent about what I'm talking about, then it's totally going to be okay, right? And we'll let this guy finish his work here, right? Great, very good. Oh, that's good too. Oh, beautiful. He's an artist. But again, so you know so space in a sense is this background grid. It's like these metric lines that we impose upon things so that then we can describe physical phenomena that are going inside. But it's not real. It's not as though I draw a circle on the blackboard. It's going to change the blackboard, or the blackboard itself doesn't change the circle. But in fact, that's so you might think that space is like that. Space is nothing. It's just some sort of like a background thing. It turns out that Einstein pointed out that this is absolutely not the case. Einstein pointed out that, in fact, there's a completely wildly different way to think about it. In fact, the way that gravity arises, the way that gravity comes into existence, the way that the force of gravity arises, is due to the fact that the presence of a certain amount of stuff within a certain volume of space actually warps and bends the fabric of space itself. So in that sense, space is actually something malleable, it's bendable. And this is a completely different way of thinking about the world. It was not just a small.
All right, it's just not right. It's magnetic. It's the more dense the matter with the black matter, the more attractive, which is gravity. So you don't have to have a huge thing to have a lot of gravity. You can have a small thing that's dense, and it could have more gravity than a big thing. All right, see, here it is right here. Density is basically mass, but you can be smaller and have the same mass because it's denser. So it said the denser planet would be smaller in size. So it would be small like that. But they would be different sizes but have the same gravity. You have one out here that's kind of fluffy, but it's big, and you have one down here small. They still have the same gravity because they have the same mass. The size doesn't matter, basically. It's how much mass you have. Mass is attributed to dark matter. Dark matter is the only thing that has mass that I know of. All right, let's let him keep going. Here he goes.
Step forward. It's a complete sea change with the way we understand the world. And so now, because of that, so for example, if I put something that has a certain density, so that you can think of space in this sense as more like instead of just a completely empty space, it's more like a rubber sheet, right? And if I put like something heavy on the rubber sheet, it actually deforms the sheet. If I have nothing there, the regular rubber sheet, and we're all stretching it tight, if I flick a little marble across there, the marble goes in a straight line, right? But if I put something heavy there, like a bowling ball or this yellow thing, and then if I push something, if I flick a little marble or something, it actually, from the marble's perspective, it's going in a straight line. But from a larger perspective, it's actually falling toward the thing that is curving the fabric of space itself. This was a wildly different way of thinking about the universe. So therefore, we have our mechanism. The moon and the earth, for example, orbit around each other because each one is falling into constantly the curved space-time of the other due to the presence of energy and matter density in space itself.
You know, that's something we'll talk about later about the moon and what its function is around the earth. But in the meantime, this is
just mind-boggling, you know, and it still is to me, and it was at the time too. So this was a very, very radically different way of thinking about the world. But it gets worse. Because it turns out that space is not just bendable. It doesn't just bend. It actually flows, too. Space is something that actually can move. Parts of space can actually move compared to other parts of space. And this has wild consequences, right? So what that means is that, so this is basically comes out of the equations of general relativity. So if you have something that has a lot of gravity, you can actually have space that's bending. It creates a kind of a sinkhole in space itself. But if
this, I got to be honest with you, this is kind of crazy. Let me come out here.
Center of the object faster than the speed of light. So not even light can escape from inside of this black hole. But if that's the case, and so you probably heard these things, I understand that for the last, 10 minutes or something, I've been saying things that a lot of you have heard a million times before. But what does that really mean? Like, if that means that space is flowing faster than the speed of light inside this black hole, beyond this event horizon, this point of no return, what does that really mean? What's actually going on inside of a black hole? That's the $1 zillion question.
What's going on inside of the black hole is nothing more than the muon parts, the black parts, are collected and pushed to the center. As I showed you, the black hole. All right, so here they are in space, and their plasma is first created in this black bucket-like chamber. Plasma just means charged particles. All right, the way I'm understanding this, the plasma they created was basically like electricity in this black bucket. Now, these micron-sized dust particles are then allowed in, and here they come. They're coming in. Now watch, they come in and they almost like line up because they're pushing each other away from each other. They don't want to touch. The white ones don't want to touch each other, but they desperately want to be attached to the black particles. So here it goes. They come in. See them lining all up like that? And then after a while, they started bouncing up and down. Swirling and all kinds of things. And then as they settled, They still have gravity to pulling towards Earth. But once they settled, it was completely unexpected. They were looking for a lattice. It was going to be lattice like that. And here's what happened. Boom, 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 boom. You see this? This is what created the black hole. He said one of the guys at the scientists from Max Planck Institute locked himself in his office for, I don't know, a couple of weeks or something. Receiving the data, he locked himself in his office for several weeks. I mean, it's freaking out. They freaked out. They created a black hole. I don't think they realized it. But what they did was they pushed dark particles to the center and surrounded them with the white particles. And then they did all kinds of other things like this here. Some of this I would have loved to have been working with these guys, because it's amazing what they were doing, but this goes back a long time ago. Now you see, you can't make the hole here on Earth because the gravity crushes it. This one's with the Russians was absolute ecology. Plasma in space experiment, English subtitles. 5 years ago I commented on it. I said I'm going to do a video about this. And I have done several of them. And it reinforces dipole electron flood theory. All right, you have seen what the photons look like, and they look like this. And gluons look like this. What's the difference? Light bounces off and you see it as light. Gluons are heat. These travel as heat. They sort of work their way in and attach to particles that will accept them. And then when it gets cold, they leave and they go somewhere else. That's what heat is. And it just travels slowly through, they're just the gluons. Now, 1,839 of these particles in one little ball is a proton. All right? But the blacks all go to the center and they're coated by the white. That's why we've never seen dark matter. Because we only see protons and up. You can't see photons of light. You just don't see them. They just illuminate things. They give off an energy glow. So we got to the photons. We got to the gluons. The photons are light. The gluons are heat. Now, we can break these two apart. Now let's go over to the other side of the equation. All right. We got the electrons and the muons. The electrons are the white part. They want desperately to be attached to the muons. That's what electricity is. You take the white, as I showed you, has no mass whatsoever. You take the black over here, and that white will do everything. It will push motors. It will burn right through you to get to that black. That's what electricity is. Lightning, static. It's just the white. All right, I showed you we got photons, we got the gluons, which are the dipole electrons, and then we've got them separated into the muons, which are just dark matter, and the electrons, which is the really glowy, energetic part, but it has no mass. That has all the mass, that has no mass. I mean, literally almost nothing whatsoever. If you took 1,000 pounds of battery and loaded it with energy, it would take 0.045 grams. 0.045 grams would be the weight. There's no weight at all. It's virtually unmeasurable. All right, we know that light is a particle because I've shown you the particles, or will, and this starts out as a wave. It starts to accelerate. That's the only reason we see it, because it is accelerating. And then once it really accelerates, you can see that the wave, actually the particle, pulls itself right out of the wave. And right about here, the explosion is so reversed that even the fields you can't see whatsoever turn brilliant, because there are photons everywhere. You just don't see them. It's just like here, you don't see them, but they're going through the air. These think they just hit the wall. They think they just hit the wall, so they turn bright. That's where you have your photons. Now, this shows the interaction right here. You see all the black balls? Those can't get through. The white gets through. But guess what? Over on this side, all the black ones come back together. Now, they didn't jump forward ahead to here. I can't believe that. I can't believe these jumped over to get back to these when they came out. So what does that leave you for a conclusion? That there has to be excess black ones laying around to jump back into these white ones, and the rest became energy. All right, the black ones are the carriers. They always are with the white ones. They're always together, except here what we broke them apart. And of course, Fermilab and CERN and all them, they smash them to bits, and they break them into little bits and pieces too. Yes, but we started with the little bits and pieces to begin with, so we didn't have to dig through all the stuff. And we can see them breaking apart here and fusing back together here. That's fission, that's fusion. There's just no other way to see it. And these black particles are the muons, and they are also dark matter, and they create gravity. I'm going to show you, I'm going to draw you a little diagram what happens when the sunlight comes to Earth. It comes as the full package, the black and the white. It doesn't come all by just the white. All right, so it comes as these particles. Now, we know that you can take a solar harvester, a solar collector, and harvest just the white to make energy. We know that. So what happened to the black? Where would the black go? The black is just going to be floating around somewhere. When light hits the Earth, I believe it can separate out to some degree. Some of it turns into heat and energy and so forth, and some of it just is the black that just lays around. And when it came through that accelerator, the ones that were black laying around in excess, because everything has sort of a weight to it. Once you get down below helium and so forth, heavier weights, they're loaded with particles, and there's a bunch of black ones laying around with them, as it appears to me. And then they jump right back in with the white. So when they talk about entanglement, it didn't entangle and jump back over here. No, I don't believe that. I could be wrong, but I don't think I am. So we've seen, and this shows that light spins in a circle. It doesn't just flap like a wave. It spins. Some of it spins this way, some of it spins over that way. So most of it goes through the center and shows up brightest in the center, because that's where the most impact is. But this easily shows you that those are, they call them interference patterns. They're not interference, they're pushing away. They're pushing and shoving. That's why they keep these separate lines. You stay away from me, I'll stay away from you. You stay away from me, I'll stay away from you. That type of thing. Light does not like to be pushing against each other. That's why you get this huge, and that's, look at the lines back here. Look at how close they are, how much of an interaction backwards is coming back. It's just amazing. Absolutely amazing. You see that? And all of that action right there at the Venturi is because of the fields being crushed against each other. Same thing they do with CERN and Fermilab, only they crush them head on. Big, huge things like this. And then everything goes flying. We did the same thing with the fields. This is field to field, crushed. We field to field sideways, because they had to get through that Venturi. It's got to be tuned right, and that's what you get. You know, it seems obvious gases are lighter and they float around and you can wave your hand through them and all that. Yes. And then all of a sudden you hit a surface that's just solid, like the Earth. Why did it change so abruptly from gases to solids? And what are the solids made of versus what the gases are made of? They're all made of the same dipoles, but they're in different configurations. The gases are like little bits and pieces that take up space. The solids are into chunks, and then you make one chunk, and then another one comes along, and it works its way in, and another one comes, and another one comes, and that's what creates matter. That's mass. That we can walk on because it's solid. You can't walk on air because there's no solidness to it. There's no real density of dark matter. This is dark matter density. And all of the electrons want to get down into this dark matter. It sounds crazy, but that's the only thing I can make out of it, is the Earth itself is saturated with dark matter. And its electrons get pulled off and circulate into the air, and they come down as lightning all the time, and rain and all that, the gaseous exchanges. So the Earth itself has more dark matter, and it lets off the electrons, and then they form in a really serious zone out there called the ionosphere. And eventually they shoot down as lightning and so forth back into the Earth, and it's just a continuous cycle. So gravity is pulling down anything that has white matter in it. And everything has white matter. Anything that's a proton has a certain amount of white matter in it. There's 1,839 of these white particles that want to get down to the Earth. And the Earth is, I say, more dense with dark matter than it is with the light matter. We know we can separate them just by using solar panels. The light hits it, you make the white go one direction to charge to use it for electricity, and then you let it come back to the black, which is the earth ground. Whenever they say ground, you have to ground stuff. Well, what do you mean, why? Because if the electricity gets loose, you don't want it going through you. You want it going to ground, and it will go to ground. You can have as much electricity as you want here, basically. If it's grounded, it won't hurt you. But if it's not grounded and you touch it, right through you to ground, and you explode like Z-bomb. All right, so as far as I'm concerned, it's particles of light emitted from whatever luminous source there is. They literally created the Earth from the dark matter. Okay, these are the particles emitted from the sun. They contain the white part and the dark part. All right, you don't get one without the other. And here's they come, boom, they hit the Earth, and the Earth absorbs a lot of the excess black. The white gets used as energy, and it gets recycled. It gets picked up through oxygen and moisture and static and all that, and gets up into the atmosphere and discharges again. But this is the ground. This is the black hole, and they found it in space by injecting dust particles into plasma, and they just lit up and pushed their dark parts into the center. It's a hard concept to understand, to think, and it blew everybody's mind, and it still does. Nobody's figured this out yet, I don't think. I don't think I have either, completely, but this does exactly what they say dark matter does. It doesn't emit, absorb, or reflect. So this is not emitting anything. We're not seeing not a damn thing. It's not reflecting anything. I'm not seeing any reflection come back from that spot. And they say it doesn't absorb. I don't know what it does. You know, if we're seeing these light particles and then that dark spot, that's hard to explain. But it shows us that this is a black hole. As far as I'm concerned, that's a black hole. All right, this just, again, proves what I'm talking about. They say there's significantly more dark matter than ordinary matter. And dark matter makes up about 85% of the universe's total matter. I don't know how they came up with that, but let's go with that. While normal matter, stars, planets, us, accounts for only about 15%. So there's much more dark matter, which we know is extremely attractive to the white. All right. Dark matter outweighs roughly 5 to 1. Now listen to this. They don't see it. They don't know it's there. I mean, they know it's there. Why? How do they know it's there if they can't see it? It's dark matter. They've never seen it. They infer its existence through its gravitational effects, as it doesn't emit or absorb light. Light is just attracted to it, and it hangs around the outside of it. The inside of our Earth has got to be filled up with a lot of dark matter, because lightning zzz, right to Earth. So the white wants desperately to be to Earth. Static, zzz, right to Earth. Electricity, zzz, right to Earth. Those three things are only the white part of the particles I've been showing you. That's only, you have to get the white away, and it makes electricity by coming back to the black. So when you get electricity coming through the atmosphere, or you get a spark from static, or you create electricity, you're only working with the white. And that's why there's so much more of the dark matter. It's in our Earth, and Earth is ground. It's the ground for the white electricity to come down and get into it. I hope that makes it. Dipole electron flood theory solves all of this stuff. It really does, and it's not a big change. It just changes the number of electrons, and they are part of the nucleus. They're not part just hanging around the outside. So anyway, thank you. Have a wonderful day.